Hello everyone. Today we are going to discuss the doubts. Okay, whatever the students have sent the doubts we are discussing today from our material. Okay, so the first one is that 1 kg NaOH, 1 kilogram NaOH is added to 10 ml of 0.1 normal HCl. So what is the weight of NaOH given here? Weight of NaOH is 1 kg. It is given weight. So weight, how many grams it is given? Tell me, how many grams of weight is given here? It is given, just a moment. So the weight is given what now here? Weight is given 1 kg. 1 kg means how many grams? 1000 grams weight is given for NaOH. After that, NaOH is base or acid? NaOH is base. NaOH is what here? Base. So this NaOH base, okay, is added to what? 10 ml of acid here. So 10 ml means how many liters? Tell me. So volume in liters is equal to 10 by 1000. 10 by 1000 liters. That means what? 1 by 100. So 0.01 liters. 0.01 liters is what now volume of acid here. And what is normality of acid? Normality of acid is 0.1 normal. Okay. And 1 kg NaOH is given. 1 kg NaOH means 1000 grams of NaOH. So 1000 grams of NaOH means how many moles of NaOH or how many equivalents of NaOH? Now number of equivalents of NaOH formula what? Number of equivalents of NaOH. Formula of number of moles what? Weight by gram molecular weight. Number of equivalents formula what? Weight by gram equivalent weight. So here weight is what now here? 1000 grams by gram equivalent weight is 40. Okay, so here 100 by 40. 100 by 40 means how much here? 25. So 25 equivalents. 25 equivalents of NaOH is there here. 25 equivalents of NaOH. And number of equivalents of acid, how much here? Number of equivalents of acid HCl is equal to formula of number of equivalents. Another formula what? Normality into volume in liters. Normality into volume in liters. So normality of HCl given how much here? 0.1 normal into volume in liters, how much here? 0.01 liters. So that is what? 10 power minus 3. 10 power minus 3 equivalents. 10 power minus 3 equivalents here. Very less it is. Less than 1. But here, how many equivalents of base is there? 25 equivalents. So 25 equivalents of base is there, whereas 10 power minus 3 equivalents of acid is there. Very less acid is there. 0.001 is there here. That's why the solution, resultant solution formed will be basic or acidic. It is basic solution. The basic solution will turn what? Phenolphthalein into what? Pink. Actually, phenolphthalein is colorless. Phenolphthalein is colorless actually. This colorless phenolphthalein will change into pink color. It will change into pink color. So this is what now to understand here. Is that clear? Now basic solution cannot turn blue litmus into red. Na? Blue litmus to red means acidic solution will turn. But it is formed what now basic solution. So only it turns what now phenolphthalein solution to pink. And they gave turn methyl orange red they give. It is also by acid only. Acids only will turn methyl orange indicator into red. Okay, and will have no effect on red and blue litmus paper given wrong. So only the second option will be right. Next, the solution having lowest molar concentration. Molar concentration meaning what? Molar concentration meaning molarity. Molar concentration is nothing but molarity. So what is the molarity here formula? Molarity is equal to, I'm erasing the remaining part. If you want, you take screenshot of this. Take screenshot of this first one. Yeah. So next, now what is given here? Molar concentration they ask. Means molarity they ask here. Now what is the formula for molarity? Molarity is equal to normality by n factor. Normality by n factor. So generally we know that normality is equal to molarity into n factor. No? N factor. So in this case now here, molarity is equal to normality by n factor. So here normality how much? 0.1. 0.1 by n factor is 1 here. Okay. So here it is 0.1 only. Now here in this case, what is normality? 0.4 by n factor 2 here. So it is 0.2. And here, what is normality? 0.1 normality. 0.1 by Here n factor is 2. N factor is 2. So it is very less here. So here 1 by 20. 1 by 20 means 0 point. 0 point. It will be 5. 0.5 it is. So 0.5 we got here. And next one what? Next one over here. This one here in this case. So 1 by equal means in fact is 1 here. 1 by 1 1 here. So 1 0.2 0.1 like this here. So it is what now here 0.1 by 2 means what? 1 by 20 na. 1 by 20 means how much here? 1 by 20 point. Sorry, just wait. Now here it is what now 100 now. So that's why what now here it is 0.0 and again 0 100 25. So 25 is what 100 here. So that is 0.05 this 0.05. So 0.05 is least value here. So 0.05 is what? Least value. That's why our answer will be this one here. 0.1 normal Na to CO3 will be having very less molarity. That is 0.05. What is my here value? 0.05. 0.05 molar Na to CO3 solution is least value here. Is that clear? So answer will be third option. Is that clear, my concept? So like this, we have to understand the concept here. Okay, next. Now here, a solution of known concentration is known as standard solution, remember. But they gave option wrong here in the key. So take it as standard solution. Standard solution means what? The solution whose concentration is known is called what? Standard solution. Next, in a normal solution, a normal meaning what here? Normality is equal to 1, remember. Normality is equal to 1 normal. Okay. Now barium chloride is given. In this barium plus 2 there, Cl minus 1 there. So each Cl is minus 1, each barium is plus 2. So each barium has what? Barium atom has plus 2 charge, each chlorine has minus 1. Okay. Now in this normal solution, normalities of Ba plus 2 ion and Cl minus ion are in the ratio they asked here. So normality of Ba plus 2, normality of Cl minus they asked here. So normal solution means what now here? 1 gram equivalent per 1 liter. 1 gram equivalent per 1 liter. So 1 gram equivalent of BaCl2 is present in 1 liter solution. Now 1 liter solution is for barium plus 2 ions and Cl minus ions. The volume of barium plus 2 ions will be 1 liter. The volume of Cl minus also 1 liter, remember. Okay. Now see here. So in this case, now what we have to understand is that, see, now number of equivalents of Ba plus 2, number of equivalents of Cl minus will be same, remember. In any compound, in any ionic compound here, in this one. In this ionic compound, number of equivalents of cation must be equal to number of equivalents of anion. So same equivalents, equal number of equivalents of barium and Cl minus, barium plus 2 ions and Cl minus ions will be combined here, remember. So same number of this one. So what is number of equivalents formula what? Number of equivalents formula what? Molarity, number of moles into n factor. Number of moles into n factor here. So number of moles into n factor is equal to what now here? Number of equivalents. Now, how many equivalents of barium plus 2 here? Number of equivalents of barium plus 2. Barium plus 2 is equal to number of moles. How many here? 1 mole. From 1 mole of BaCl2, how many moles of barium plus 2 will be formed? 1 mole barium plus 2 is formed here. And how many moles of Cl minus will be formed? 2 moles of Cl minus will be formed. Why? 2 Cl atoms are in 1 molecule. That's why how many moles of Cl minus will be released? 2 moles of Cl minus will be released. 1 mole barium plus 2 will be produced here. That's why here number of equivalents of barium plus 2 is equal to number of moles of barium plus 2, 1 mole into n factor of barium plus 2 is 2. Because charge is what? 2 na here, plus 2 na? That's a 2. That is equal to equivalents of barium plus 2. Barium plus 2. And what is normality? Number of equivalents by volume na here. So what is normality here? So normality equals to number of equivalents. How many? 2 equivalents by 1 liter. So 2 by 1, 2 normal solution it is normality. And next one, number of equivalents of Cl minus is equal to number of moles of Cl minus. How many produced here? 2 moles produced here. So 2 moles of Cl minus into what is n factor of Cl minus? 1. Charge on Cl minus is what? Each Cl minus 1. So here it is equal to 2 equivalents of Cl minus. So number of equivalents of Cl minus how much? 2. So again Cl minus volume also 1 liter only. So normality of Cl minus also 2 equivalents by 1 liter. Again same, normality will be same. That's why the normalities of Ba plus 2 and Cl minus will be in the ratio 1:1. So normality of Cl minus, normality of barium plus 2, both will be same. So normality of what? Cl minus and normality of Ba plus 2 or normality of Cl minus. Both will be equal to what now here? Both will be equal to 2 only, 2 normal solution. That's why 1:1 ratio we take. Let's take the screenshot of this one. So number of equivalents formula what? Number of moles into n factor. Okay. Like normality equals to molarity into n factor. Na? Like that, number of equivalents is equal to number of moles into n factor of the ion. Next, the equivalent weight of Morse salt. The equivalent weight of Morse salt. So Morse salt is given what? Ferrous sulfate, ammonium sulfate, ferrous sulfate, and ammonium sulfate, and what here? 6H2O. Ferrous sulfate, ammonium sulfate, 6H2O is called Morse salt. So here Fe plus 2 ion is present in this. What is ion present? Fe plus 2. So during redox reaction, what happens is that this Fe plus 2 will go to Fe plus 3. Remember, Fe plus 2 will be oxidized to Fe plus 3. So Fe plus 2 is what? Oxidized. Fe plus 2 is oxidized to what? Fe plus 3. So Fe plus 2 is oxidized to Fe plus 3. So here what is the change in oxidation state? 3 minus 2. So what is n factor now here? Therefore n factor is equal to 1. N factor is equal to 1 here. Change in oxidation state is equal to n factor. So n factor is 1 here. That's why what happens now here? The equivalent weight. The equivalent weight is equal to what? Equivalent weight formula what? Gram equivalent weight formula is equal to gram molecular weight by n factor. Here n factor is what? 1. N factor is equal to 1. That's why gram molecular weight by 1 will be equal to gram molecular weight. So gram molecular weight is equal to what? Gram equivalent weight for Morse salt. Is that clear, ma? So Fe plus 2 is going to Fe plus 3. So how many electrons lost? 1 electron lost by Fe plus 2. Fe plus 2 ion has lost 1 electron to form Fe plus 3. That's why n factor is 1 here. Next, what is n factor of this type of species here? Oxidizing agents and reducing agents. Number of electrons lost by 1 molecule. Otherwise, number of electrons gained by 1 molecule. 1 molecule gains how many electrons is called n factor. Otherwise, 1 molecule loses how many electrons is also called n factor. The number of electrons lost by the molecule or number of electrons gained by 1 molecule will be called n factor. Next, equivalent weight of ammonia. Ammonia formula NH3. NH3 gram molecular weight how much? Gram molecular weight 17 grams per mole. 17 grams per mole is what? Gram molecular weight of ammonia. So the equivalent weight of ammonia as a base is what? Now generally NH3 with one lone pair on nitrogen will accept 1 proton. 1 proton will be accepted to form NH4 plus ion. NH4 plus ion means what? Ammonium ion. See how many H plus ions gained? How many H plus ions gained by ammonia molecule? One molecule is gaining what? 1 H plus. Okay, so it can accept what? 1 H plus. That's why n factor is what? 1 here. For this n factor is what? 1. So n factor of ammonia is what? 1. N factor of ammonia is equal to 1. That means what? For this base, what is the acidity value? 1. Acidity means n factor. For any base, what is acidity? Acidity is nothing but n factor. N factor of this base ammonia is equal to 1. That's why what is gram molecular weight here? 17. And what is gram equivalent weight formula? Gram equivalent weight is equal to gram molecular weight by n factor. So gram molecular weight 17 by n factor 1. That's why 17 will be gram equivalent weight. N factor of ammonia is what? 1. So next, in the reaction I2 plus 2H2O3, it is called thiosulfate. Thiosulfate. Yesterday one problem we discussed, sodium thiosulfate. Thiosulfate ion is nothing but H2O3 minus 2 ion. So how many moles of thiosulfate? 2 moles of thiosulfate and 1 mole of iodine. So 1 molecule of iodine it is. 1 molecule of iodine has how many atoms? 2 atoms. And iodine is converted into what? I minus. So each iodine, okay, converted into I minus by gaining what? 1 electron. 1 electron is gained by 1 atom. But how many atoms in this iodine molecule? 2 atoms there. Now 2 atoms will gain how many electrons? 2 electrons. Each iodine atom gains 1 electron. 2 iodine atoms in one molecule gain what? 2 electrons. Now totally iodine molecule gaining how many electrons? Gaining 2 electrons. Now total number of electrons gained by one molecule, how much? 2. Therefore, n factor of ammonia is what? 2. N factor of ammonia is what? 2. Why n factor is 2 here? One molecule of ammonia, sorry, iodine. One molecule of iodine is gaining how many electrons totally? 2 electrons. Because each iodine atom gains 1 electron. 2 iodine atoms gain 2 electrons. Therefore, n factor of iodine molecule should be taken 2. When n factor is 2, gram equivalent weight is equal to what? Gram molecular weight by n factor. So molecular weight by 2. So half of its molecular weight we have taken. So gram equivalent weight is equal to what? Gram molecular weight by what? N factor of how much here? 2 for iodine. So like this we take. Next, the equivalent weight of CH4 in the reaction. In the reaction, what here? In the reaction CH4 plus 2O2 gives rise to CO2 plus 2H2O. It is called combustion of methane. What is the reaction called? Combustion means burning any substance in air. Combustion of methane. Combustion means complete burning of a substance in air is called combustion. Methane formula CH4. In this, carbon has what now here? Oxidation state 4. Oxidation state is what? 4. Each hydrogen plus 1. Na? Each hydrogen how much? Plus 1. And the carbon is what now here? Carbon is what here? Minus 4 we take. But minus 4, carbon with minus 4 is unstable. Carbon with minus 4 is what? Unstable. Okay. So unstable means what now here? C minus 4 cannot exist or here in nature generally. But in this year, relatively, if you take, when hydrogen is having plus 1, so 4 hydrogens will have plus 4. Then carbon alone should be having minus 4 generally from this concept. Next here, carbon has what now here? Plus 4. Carbon has what? Plus 4. Now oxygen, each oxygen minus 2 we know already. Minus 2 into 2, minus 4. Then to balance minus 4 of oxygen, there should be plus 4 on carbon here. So minus 4 to plus 4, what happens now here? Minus 4 to plus 4. How many electrons are involved here? Minus 4 to minus 3 means one electron is gained. Minus 3 to minus 2, one more electron is gained. Like this, minus 4 to minus 8, 8 electrons are gained. 8 electrons are gained. Totally, how many electrons gained? 8 electrons gained. Okay, 8 electrons are gained by what? This minus 4, C minus 4. That's why here we take number of electrons gained by one molecule is what totally? It is 8 electrons. That's why here what we have to general n factor is taken what? Molecular weight by n factor. Molecular weight by n factor we take here like this. Okay. So no, not this one. This one. This one is correct. So whatever the students have sent the doubt, I'm sending here. Okay. And also understood concept here. Hydrogen each one plus 1. Plus 1 into 4. Plus 4. Then carbon minus 4 should be there. But here in CO2, what happened here? Carbon has got plus 4. That means carbon has changed from minus 4 to plus 4. Minus 4 to plus 4. If you take minus 4 to plus 4, what happens now? How many electrons gained? 8 electrons gained totally. That's the number of electrons gained by one molecule of methane is 8. Therefore, we take n factor as 8. When n factor is 8, we take gram molecular weight by n factor 8. But in other concept here, in some books, they will be taking like this here. Yeah, as CH4 is what your methane and carbon cannot easily form minus 4. We have to take another concept is that now the valency of carbon is 4 here. The valency of carbon, how much? Valency of carbon is 4. And valency of hydrogen, how much? 1. Valency of hydrogen, 1. But generally, we also take n factor is equal to n factor or valency factor, we say. N factor or valency factor. So valency factor or n factor is equal to atomic weight of carbon by valency of carbon plus atomic weight of hydrogen divided by valency of hydrogen. Now tell me from this atomic weight of carbon how much here? 12. By valency of carbon how much? 4. Valency 4. And atomic weight of hydrogen how much here? 1. And valency of hydrogen 1. So 12 by 4 how much? 3. 3 plus 1 how much? 3 plus 1, 4. So totally we got n factor is equal to what? 4. When n factor is taken 4 now, we should take what? M by 4. We should take m by 4. In some books it is taken m by 4. In some concepts they are taking m by 8. Okay. So as what here the CH4 molecule is what here covalent compound. As it is covalent compound. And here carbon is forming how many bonds around it? 4 bonds it is forming with 4 hydrogens. As 4 bonds are formed by carbon, you take carbon valency as what? 4. And this concept you better take. So you take m by 4 only here. M by 4 you take instead of m by 8. If you take oxidation state concept, we get m by 8. If you take valency factor concept, if we take, it will be m by 4. So you better take m by 4 only because CH4 is not ionic compound. It is covalent compound. The C minus 4 is not possible to form easily. So you take m by 4 only answer here. Okay. Take the screenshot of this. Yeah, next one, assertion. Okay, so assertion and the reason type here. So now in this, what is given is that the volume of 0.1 molar. So molarity given. What is given? Molarity. Molarity of which substance KMnO4? It is what? Oxidizing agent. So oxidizing agent means what? It undergoes what? Reduction. Undergoes reduction. Undergoes reduction means what? Gains electrons. It gains what? Electrons. So oxidizing agent KMnO4 undergoes what? Reduction. Any oxidizing agent must itself undergo. It must undergo what? Reduction. Reduction means what? It must gain electrons. How many electrons will be gained by KMnO4? We have to understand. In KMnO4, manganese has how much charge? +7. Manganese has what? +7 charge. Remember. Now the volume of 0.1 molar KMnO4 required to oxidize 20 ml of 0.1 molar oxalic acid. Yesterday I told you oxalic acid formula. H2C2O4 to H2O. Oxalic acid. For oxalic acid, N factor, how much I told you? N factor is equal to 2 for oxalic acid. And for KMnO4, which medium it is taken? Acidic medium, na? In acidic medium, KMnO4, manganese +7 will go to manganese +2 always. Mn +7 charge will change into Mn +2. So what is change in oxidation state? 5. Therefore, N factor should be taken as what? 5 in acidic medium. For KMnO4 molecule, N factor should be taken as what? 5. Is that clear, ma? And now here we have to take N1V1 of KMnO4. KMnO4 must be equal to N2V2 of oxalic acid. Now tell me here. Now normality of KMnO4 is equal to what? Normality formula was generally molarity into N factor, na? For KMnO4 molarity given how much? 0.1. 0.1 into what now? What is the N factor of this? N factor of KMnO4 is 5 here. In acidic medium, it is 5. So it is this normal into V1 of KMnO4 we need. V1 of KMnO4 we need here. Is that clear, ma? Is equal to N2 of oxalic acid. For oxalic acid, how much molarity given? Molarity 0.1 into N factor of oxalic acid 2. So this is normality of oxalic acid into Volume of oxalic acid given what? 20 ml. 20 ml. Now we need to calculate V1 here. Now V1 is equal to what? Tell me. 0.1 into 2, 0.2, 0.2 into 20. So now V1 is equal to 0.2, 0.2 into 20 divided by, it is what? 0.1 into 5, 0.5, 0.5. Okay, it is what now here? 40 by 5. 40 by 5 means how much? 8 ml. 40 by 5 means what? It is what now here? 8 ml. Is that clear, ma'am? So this is what now here, concept of what? This one. 8 ml of KMnO4 is required actually here to completely neutralize what? 20 ml of oxalic acid. But if they gave what here? Required is 20 ml they gave. Is it right? No, it is wrong. That's why here assertion is what? False. A is false. Assertion is false. Fourth option check. Fourth option. Assertion is false. But R is what? Reason. Reason is given what now? 2 moles KMnO4 is equal to 5 moles of oxalic acid in acidic medium reaction. That means 2 moles of KMnO4 will be required to completely neutralize 5 moles of oxalic acid. Means 2 moles of KMnO4 will completely react with what? 5 moles of oxalic acid. So here 2 is what? N factor of oxalic acid. N factor of oxalic acid. Here 5 is what? N factor of KMnO4. 5 moles of oxalic acid means the 5 is what? The N factor of KMnO4 in acidic medium. And what is this 2? 2 is the N factor of oxalic acid. So this reason is correct here. Reason is correct. So 2 into N factor of oxalic acid into KMnO4. These many moles of KMnO4 will be required to neutralize what? N factor of KMnO4 into moles of what? Oxalic acid. Number of moles of oxalic acid. So only one thing remember, that 2 moles of KMnO4 will gain 10 electrons totally, because one mole KMnO4 is gaining how many electrons? Here plus 7 is there, converted into plus 2. Means how many electrons gained here? 5 electrons gained. 5 electrons gained. So one molecule of KMnO4 is ready to gain how many electrons? 5 electrons. Then here totally 2 moles of KMnO4 will gain how many electrons? 10 electrons. 2 moles of KMnO4 will gain what? 10 electrons. Now from where 10 electrons coming? From oxalic acid molecules. Each oxalic acid molecule will produce what? It will lose what? 2 electrons. Each oxalic acid will lose how many electrons? 2 electrons. In fact, is 2 now here. Each oxalic acid molecule will lose 2 electrons. Then how many electrons should be lost totally? 10 should be lost, 10 electrons. But each oxalic acid loses 2 electrons. 2 into 5. 2 into 5, 10 electrons will be lost by 5 moles of oxalic acid. And each KMnO4 will gain 5 electrons. 2 moles of KMnO4 will gain 10 electrons. So the number of electrons gained must be equal to number of electrons lost. So that's the reason is correct here. Let's take the screenshot of this. Next, Henry's law constant for solubility of N2. Solubility of N2 gas here. So it is what now at this given temperature. At the given temperature, what now? KH is given. What is this value? KH. KH means what? Henry's law constant. For which gas? Nitrogen gas. KH of nitrogen is given what? 1 into 10 power 5 atm at the given temperature. The mole fraction of nitrogen in air is given here. So mole fraction of nitrogen in air it is. Mole fraction nitrogen in air is given what now? 0.6 is given. Next, mole fraction has no units. Do you know? Do you know or not? Mole fraction and what here? Mole fraction doesn't have any units because it is a fraction simply. Next, the number of moles of nitrogen from air dissolved in 10 moles of water. So number of moles of water, how many? Number of moles of H2O, 10 moles. So 10 moles of H2O is taken. In this 10 moles of H2O, what is dissolved? Nitrogen is dissolved. What is dissolved? Nitrogen is dissolved. So n moles of nitrogen is dissolved. Now we have to get how many? Now we have to get this n value. Number of moles of nitrogen dissolved we have to get. Number of moles of H2O given what? 10. of water at 298 Kelvin. Again, same temperature. Temperature is maintained same. And 5 atm pressure. Now total pressure is what now here? Total pressure. Total pressure is equal to 5 atm. So total pressure is given, and mole fraction of nitrogen in air is given. Mole fraction of nitrogen in air is given. Now we have to get number of moles of nitrogen in water. Number of moles of water in number of moles of nitrogen in water we have to get now. Remember. Now, so what is here? Now total pressure given how much here? Total pressure is given how much? Total pressure is given 5 atm. Pressure of total means total pressure of mixture. Total pressure of what? Mixture. Gaseous mixture is given 5 atm. And X of N2 means mole fraction of nitrogen in air. It is what? In air. Mole fraction of nitrogen in air is what? 0.6. And partial pressure. PP means partial pressure. Partial pressure of nitrogen is equal to mole fraction of nitrogen in air into total pressure. Is that clear, ma? So it is what now? Mole partial pressure of nitrogen in air. Partial pressure of nitrogen in air is equal to what now? Partial pressure is equal to mole fraction of nitrogen in air into total pressure of air mixture. Air is what mixture, na? For the air gaseous mixture, the total pressure is given 5 atm. 5 atm total into mole fraction of nitrogen is equal to partial pressure. So 3 atm is what now? Partial pressure of nitrogen, remember. Okay. Now here, according to Henry's law, when you dissolve the gas in water, what we dissolved? Nitrogen gas is dissolved. The nitrogen gas partial pressure, how much here? Partial pressure 3 atm we got. 3 atm. Now according to Henry's law here, the partial pressure is equal to what? P is equal to what we studied. P is equal to K into mole fraction, na? K into solubility. KH into solubility is equal to P. P means what? Partial pressure of nitrogen is equal to K of nitrogen. KH value for nitrogen is given. KH value for nitrogen is given into mole fraction of nitrogen. Mole fraction of nitrogen in water now here. Mole fraction of nitrogen in water, not air. Mole fraction of nitrogen in water, in the water given. Okay. So KH value given, it does not change. As temperature is same, we have to take same KH value given. And PP already we got, partial pressure we got, that is 3 atm. So now what we have to equate here? Now the PP is equal to KH into X. Then X is equal to what? Mole fraction of nitrogen in water. Mole fraction of nitrogen water is equal to what here now? X is equal to what? Partial pressure 3 atm by KH. 3 atm partial pressure by KH value given what? 1 into 10 power 5 atm. Therefore, what now? 3 into 10 power minus 5 is what? X, mole fraction. No units here, mole fraction. So mole fraction of nitrogen in water. Mole fraction of nitrogen in what? Mole fraction of nitrogen in H2O, in water. Now that is equal to what? The number of moles. Mole fraction formula what? Mole fraction. Mole fraction formula, number of moles of nitrogen by total number of moles. Total number of moles means what here? N. 10 moles of nitrogen or water plus number of moles of nitrogen. Number of moles of nitrogen by number of moles of water plus number of moles of nitrogen. But here, N value will be always very less than 10 moles. That's why what we take now, therefore we take what? 10 plus N will be taken what? It will be taken what? Nearly equal to 10 only. As N value very less than 10. So we take this one, this condition. That's why we have to take what? Only here? 10 only. N by 10 you take. N by 10. Then what here now? Mole fraction 3 into 10 power 5 is equal to number of moles of nitrogen in water by number of moles of water. Then N is equal to number of moles of nitrogen is equal to what? 10 into this 3 into 10 power 5. That equals to 3 into 10 power minus 4. 10 power minus 5 into 10 power 1, na? It will be 10 power minus 4. So number of moles of nitrogen, how much now? 3 into 10 power minus 4 moles in water. These many moles of nitrogen is dissolved in water. Is that clear, ma? Once take the screenshot of this. The remaining questions we'll discuss in the next class. Okay, bye. Good day.